today what we will be learning about is graph machine learning. And it's because nowadays we see a lot of hype about OpenAI, ChatGPT, GPT-3 models, large language models. So we will learn about graph machine learning and how it is very easy and very, intuitive to build graphs with OpenAI. Right. So we will see graphs the traditional way. We will understand why we need graph machine learning. And then we will see how easy it is to, implement graph machine learning with OpenAI. So we'll have a lot of demos and, we'll have a lot of fun with ChatGPT today. So stay tuned. So quickly about me, I'm a Microsoft AI MVP for 3 years now, and I also lead the AI IoT business for Southeast Asia region for my company Avanade. Avanade is actually, a combination of Accenture and Microsoft. So I lead the entire AI IoT business for Avanade. And I also represent sustainability for Southeast Asia. So I also support a lot of AI for sustainability. And if you want to connect with me, I'm always available on my LinkedIn or on my Twitter handle, right? So let's start into our topic, right? So nowadays, when we talk about large language models, typically what we see with ChatGPT or OpenAI or DALL-E, these kind of huge language models. So what they are aimed at, what is it what they want to achieve? So what they do is actually their goal is to mine knowledge. So there's a lot of information around us in the form of text, audio, documents, images, right? And how to combine all that information together and use it for mining meaning deriving insight, useful insights, deriving actionable insights, using all that knowledge to come up with a new knowledge, right? So I might have a lot of images with me. Now how do I combine those images creatively, innovatively, and create something different? How do I combine all the text knowledge which I have within my enterprise, outside my enterprise, to now gather it and help me make decisions? So this is what all these current large language models, which we call as LLMs, are aimed at. So they want to ingest all the data which is out there. They will enrich it with capabilities like extracting images from your documents, or converting your translating your languages, the document in your languages, or text in your languages to another language. And then they explore. So whatever they have ingested and enriched, then they explore that and come out with answers to your questions, or come out with a new generative content to your questions, right? So typically now you can easily ask a chat GPT that hey, give me an article about what should I talk on International Women's Day about empowering women, and it will be able to give you that content. So that is what we call as generative AI. So they ingest the knowledge which is made available to them historically. We enrich it, and then they are able to explore the same knowledge or come out with a new knowledge altogether, right? So this is all about what we nowadays learn about knowledge mining. Now, why do we need knowledge mining? I don't think I need to explain this point, because we all know why we need knowledge mining. So there's a lot of information out there, right? Like, as I said, in the form of your social media content, digital content, videos, audio, text, your enterprise documents. There's a lot of all of these, information available out there. So we can see here, right? There's an information explosion. Okay, but the ability to analyze is limited. So there is this analysis gap here. Okay. And the footprint of unstructured information in our workplaces is growing, right? So now you have your team meetings, you have your Zoom meetings, you have documents shared in the form of PPT, Excels, doc files. Then you have your Outlook emails coming in, and so unstructured information is growing exponentially. And the actual value lies in tapping that unstructured information, right? So critical business functionalities actually depend on all these unstructured information. So a lot of times when we go to client side, right? So client asks me that, so especially like insurance companies or banking financial sectors, they tell me that, hey, I have a lot of information in my KYC documents, right? And can your AI help me to extract all this information and give me meaningful insights, like, which age group should I target to sell this policy? Which is the age group which I want to target if I want to bring out a new credit card? So these kind of running these kind of campaigns, running these kind of new schemes is where they want to look at actually extracting this knowledge from a variety of unstructured data and then help them actually making decisions. And currently, the methods to extract and understand that unstructured information is very limited. So even with the help of OpenAI and ChatGPT and all of this generative AI, there is still, this gap for how we are going to actually harness this unstructured information, correct? And manual methods like, the banks doing this, reading this KYC manually, or, investment managers reading the portfolio analyst report manually, that takes a lot of time. It is, of course, error prone. You're not able to capture all of the data, right? So you will just capture the keywords unlike a machine. And then there is always this challenge of growing volume. The volume keeps on growing, whereas the analysis power is limited, and that is why you're not able to maximize the value, right? So you're not able to derive the maximum potential of from your unstructured data, right? So this is a very nice diagram. I like this diagram very much. So you see, you have a lot of, data available. It could be relational, it could be files, it could be diagrams, it could be forms. And then you have all this data mess here, right? It's all a jumbled data jungle, what we call as data jungle. And we call it as dark data, okay? Now you need to be able to actually mine this dark data. So what we call it as reach the unreachable. So what is the story which your data is trying to tell you? Come up with that hidden insights from your data is what current machine learning systems or knowledge mining systems are targeting, right? Correct. So it's a very, it's a very telling slide that how actually your data actually gets jumbled up and how then we need AI to make sense of that data, right? So for example, these are your forms. Okay. So your forms might have some stamps, your forms might have some written text, your forms might have some, pre-selected things like check boxes, radio buttons, and dates and all of that. So we need to be able to extract these things from the forms or documents and then need to make sense of what it is or what is, which field is giving us most business value and kind of stuff, right? Okay. So, and what are the benefits of knowledge mining? So, of course, save time and money, improve decision making, prevent loss of information, right? So, because as I said, I'm reading manually documents, a lot of information I might just skim over or I might not capture. Improve compliance. So if there's a compliance need for your, security or insurance or risk, these kind of things or governance, then of course it will help you improve compliance. Unlock advanced analytics use cases like pattern recognition, anomaly detection kind of stuff, insight into unstructured data, and the most important is making your knowledge searchable. So just for this part, all of this time when you were searching on google.com, right, what it did was it definitely made knowledge searchable by by giving you the ability of presenting you documents which had the most closest correlation with your search query, right? Now we've gone a step further, and apart from just making knowledge searchable, we are also making knowledge generative. So if I'm asking something to Google right now, let's say, what is OpenAI GPT-3, then Google will give me certain links which are pointing me to the website of GPT-3, or it will give links which, to articles which are talking about OpenAI GPT-3. But now when I open Chat GPT and I ask it, hey, what is OpenAI GPT-3? It can actually give me a very concise, very precise answer. So it is not only making knowledge searchable, but it is also making knowledge, generative and attainable, right? So I need not click hundreds of links and extract the most relevant paragraph or most relevant text, but now actually that text is, hand delivered to me, right? So these are all the knowledge mining benefits. When we talk of use cases, of course, digital content management, then there will be data extraction, customer support and feedback, technical content review and research, and auditing and compliance management. So how does knowledge mining help in customer support and feedback analytics is, your for banks especially, or for your marketing, branding, these kind of stuff, for your reviews on Amazon, how to harvest those reviews, how to analyze the sentiments, market sentiments. It could be for a stock, it could be for a product, it could be for a company, and then accordingly, design your marketing decisions, your branding, your target sector, target audience. And then now there are a lot of things which are talking about hyper personalization, right? Hyper personalization, customization, customer insights, analytics. So these are the things which, when it comes to your customer support and feedback analytics, knowledge mining will help, right? Of course, it will help you in data extraction. Digital content management is your, organizing your digital content. So top viewed videos, your TikTok viral content, or all of your social media feeds, articles, these kind of content management, right? What to censor, what to sort of show it on the top, what is the trending hashtag of the day, all these kind of management, digital content management, right? And the scenarios and industries where we actually have this search which is relevant, and the need for this kind of knowledge mining is when we talk of, internal line of business search, right? So a end user in a very huge organization may want to just ask a chatbot a question saying, hey, I want to search this repository and now give me the data, right? So because in enterprises, data sits in databases, data sits in SAP systems, data sits in unstructured documents, PDF documents, and so many, legacy and cloud systems, SharePoint, on-prem, SharePoint, on cloud, all of these various places. And my question can be, answered from data from a lot many places. Like there's no one particular document which may be able to answer my question. My question could be, answered by different parts of which are residing at various data storage locations, right? So this is where, employees typically want sort of a central knowledge lake, what we call as a knowledge lake, and they should be able to search it, right? So information wherever it is scattered in different storage locations, different directories, different documents, it should be collected and presented to the user. Okay. So this is where, line of business search knowledge mining comes in. So people typically want to search all the information, especially in manufacturing, finance, legal, sales, asset heavy industries, right? And then there is also a need for linking and document matching. Okay. So when when I'm searching for a particular report, okay, let's say in a legal agency, in a lawyer firm, right, then I should be able to get back past cases or past records which are similar to what I'm searching. So these kind of, sentence similarity, document similarity, based on the question of the user, right, based on the UI query, these documents should also be brought up. And these are, anyways, customer facing search, which is your bot, typical bot, and, your knowledge advisor, right? So for example, I want to now query a database and then go down to the granular level of all the attributes of that particular data. Or I want to, ask questions like, give me the top 10 sales of top 10 products with the maximum sales for this quarter, and slice and dice by, I don't know, like, particular category, which is FMCG or retail, and these kind of questions I would want to ask, right? Okay, so typically, let us look at some of the ways in which knowledge mining is currently used. Okay, so let's assume a fictitious person called Farooq. He's a project planner and he has a challenging project at hand. Okay, so now Farooq is, thinking that I wonder if I could, learn from similar problems from the past to plan my new project or execute my new project. So he's thinking of, he's somewhere from a shipping industry, right? A heavy asset heavy industry. So he has questions like, what issues did previous engineers and project planners face? What are the similar equipments they used and where are they located? what do they recommend? How can some problem be prevented? Are there, parts available? Who are the experts if I want to probably, ask for some machinery question? What was the budget? Was this a brownfield or greenfield project? So all of these questions he needs to answer, and probably, the equipment related questions will be available in some other database. The experts related question will be available with the skills database, which is with the human resources, right? Project related, planning related information could be residing somewhere else, at some other operations level information, right? So, so unstructured data requires a holistic approach to enable trace, trust, and monetize. So we are not only just, making the data searchable, but also we should be, we are enabling the organization to monetize the data to maximize their current business decisions. Okay, right? So for example, as you can see, let me, play the animation for this slide. Otherwise, it will not make any sense. Let me put it in presentation mode. Yeah. So you see, this is a engineering diagram of a particular plant, right? So this what you see on your screen is an engineering diagram, right? So this is just what we call as a piping and engineering diagram of a fire distribution flow for process and utility area. So there are, manufacturing manuals, operation specification, maintenance guidelines, historical logs. So there will be like how different pipes are connected, and then it is very challenging to obtain the correct knowledge, right? So any engineering decisions of, where to put a particular vault, or where to fix if a particular valve is broken, what kind of pipe to use, these will be very difficult decisions to make if we are not able to read this diagram, right? So this diagram typically is a mine of information. It has lots of information which could be very useful. As a human, how do I, make this information usable to me? There will be very few people who will be able to understand parts of this diagram. But as an end user, if I want to search something like, hey, what if, particular valve is broken? How do I fix it? Where do I fix it? What are the, manuals where they will tell me how to do this kind of configuration or fixing, right? So that is why, all of these, knowledge mining things and making knowledge available, searchable becomes a huge challenge. Okay. And it could cause fatalities as well. So for example, the Phillips 66 plant explosion, some wrong configuration caused the release of ethylene during the maintenance of a branch line, and it caused a lot of, fatalities. So that's why there is a strong demand for knowledge mining, right? And especially asset heavy industry. So anyways, software industries will have all of this data somewhere digitized and stored, but asset heavy industries where they have these kind of PDF drawings or drawing sheets, how do they digitize their content and, enable knowledge mining? Okay. So as we talked of our engineer Farouk, right? So let's say, a user asks a question, I have corrosion issue at various places in my pipeline. How to repair my pipeline quickly? Correct. So this one question can have answers in multiple documents. So first of all, when we talk of corrosion issue in a particular pipeline, there will be an engineering drawing you see at the top here, the engineering drawing. Then you will have equipment maintenance and manual logs which talk about how to prevent corrosion. And then, you will have the need for this kind of a graphical information where it tells you that, what is a pipe, what is a corrosion, which pipe can cause, how corrosion can affect a pipe, what are the subtypes of a pipe, what are the things which can fix corrosion. So these particularly these kind of things will come in, and this is where a graph will help you make sense of your information. Okay. So you will see this, right? So when we talk of corrosion, then I should be able to look at the various pipelines. So these you see here, these green things are what we call as entities or nodes in a graph. Okay. And then I will be able to see that, okay, corrosion affects which kind of pipes? What are the components of those pipes? Do those pipes have any other relationships? Like, for example, you see here, they have a relationship for something called as maintenance manual logs, right? Okay. And what are the different types of equipment here? So you will see that you will have information about operations, maintenance, PMO, project, quality analysis, instrument, process, engineering. production, abandonment, all of these. So which is what we were looking at on the onset, right? So when I'm asking a question, I should be able to combine information from various aspects in my enterprise, various, data sources in my enterprise, and come up with a holistic answer. This is where your graph machine learning comes in, right? So this is where, you will have graphs, knowledge graphs. So you will have concepts, right? Where like, concepts are something what we call as corrosion, right? So corrosion. Entities are like your classes, right? So entities meaning, for example, a pipe is an entity, okay, or a valve is an entity. And then you will establish relationships between those concepts and entities. For example, amine corrosion affects your steel pipes, okay? So a pipe becomes an entity. Then steel, like, becomes a type of the pipe. So pipe can be a steel pipe, it can be a iron pipe, or I don't know, like lots of pipe. Corrosion can be amine corrosion, chlorine corrosion, brine corrosion, so many types of things. So basically you are trying to create nodes and relationship between nodes, okay, via a graph, right? Uh, so yeah, so complex engineering question can be answered by, leveraging the data which is available in structured and semi-structured documents, right? So we won't go into the specifics. I just want to show you one simple thing, right? Okay. So this is how, we are making the knowledge available, right? So this you see is a diagram, okay? And this is the mechanical data sheet, which will explain you that this is a pipe and it is connected to another pipe. This is a valve. So we meaning the AI models are actually reading the drawing and making a table like this, right? So equipment number 1 is a type of heat exchanger and it has 4 nozzles. Equipment number 2 is a tank and it has 6 nozzles. And how are they connected? So you see here that line number 1, spool 1, okay, is connected to tank 1. And these are the properties at a temperature of 120 degree and pressure of 10 kilowatts, okay, and same, so on and so forth, okay. And when we talk of graphs, everything is about triples. So there will be a subject, there will be an object, and there will be a relationship between them, right? So for example, Villa Nelcott is located in France. So this is one entity, this is one entity, and this is the relationship between them. To make it simple, I can say that, this is a person related to another person. So it could be like Priyanka is friends with the Shulamite, okay, something like that, okay. And then we define entities. Entities meaning, as I said, right, like when we talk of two persons, or person and department, or employee and department, or employee works in some particular office, right? So these kind of high level classes, what we call as are entities, right? Then we define the relationship between those entities and we express these as graph relationships. So tank is, so here something like, let us go here. Yeah. So you see here, like, okay. So this gate valve connects to something. Piping spool is a type of something. So these are all relationships and these are all entities. And they will then, we will see that what is piping spool, how it is connected to nozzle, what is the heat exchanger, how it is connected to something, right? So all these kind of entities relationships are defined. Okay, and now why this, defining entities and relationships in a graph is important. So let's say if I have a instruction like this for my quality control, where I'm talking of a vertical tank's operating pressure is above 1000 kPa, then a connected pipe must have a double block valve, right? So when I'm reading a drawing and I want to do quality inspection of parts, so I read this rule, which is defined by my engineers or my operating manual, saying that, vertical tank's pressure is above 1000 kPa, then it should be a double block valve. And we have already taught the machine what is a pipe and what is a double block valve, right? So you will be able to see that this particular drawing is rejected and this particular drawing is approved, because I know that, this tank is now connected to a single block valve. But if the pressure is 1000 kPa, then the tank must be connected to a double block valve. So now the machine can make decisions based on the knowledge graph about whether parts are rejected or approved, right? So which is why graph machine learning becomes very, very, very powerful. And then this is, a reasoning and safety what we gave, right? So if just small negligence because of these kind of, double wall, single wall can lead to billions of dollars of loss of lives, right? So now we've talked a lot on knowledge graphs. Let us actually look at a practical example of a knowledge graph. Okay. So let me show you something which is, yeah. So this is a COVID-19 demo which was built on Azure cognitive search. Okay, so let me search something like ibuprofen. Uh, right. Yeah, right. Ibuprofen. And then I'm searching for ibuprofen and it will give me documents which are mentioning ibuprofen and it are highlighting ibuprofen. Now, there's a lot of things which I have to actually go through, and I'm just searching for ibuprofen. Now it could be I want to check what are the authors who have written papers mentioning ibuprofen, what are the diseases which ibuprofen can treat, what are the symptoms or side effects related to ibuprofen, what are the some of the body parts which ibuprofen affects. So I want to specifically search about these kind of things, not just articles. I don't want the headache of opening each and every article and checking what I really want to search about ibuprofen, which is where I will then go to explore my graph relationships. Okay, in the graph relationships now, whatever is the central of your, so I searched for ibuprofen, right? So this is the center of my search, and then I can actually, so these are called as the facets. Okay, so what do I want to check the relationship between? So now these are the relationships between ibuprofen and the papers, so the people who have written papers mentioning ibuprofen, right? So these are actually the contributors or writers who have written some journals or scientific papers on ibuprofen. So I can also look at, for example, diagnosis. So what are the some of the diagnosis which is related to ibuprofen? So for example, ibuprofen, what can it treat? It can treat influenza, it can treat respiratory diseases, it can treat coronavirus infections, and it can treat inflammation, pneumonia, these kind of stuff. So I will be able to find these kind of relationships between various entities. So here see there are many entities, contributors, body structures, diagnosis, and I will be able to check the relationship of my search term. So here I just search for ibuprofen, but imagine if I had searched for something like a very complex term, like what are some of the side effects of consuming ibuprofen when I am diagnosed with COVID-19 Omicron variant. Okay, Omicron variant. Then in that case, I should be able to understand what are, what are the diagnosis for Omicron, who are the, what are the genes which are affected by these kind of stuff. So this is where knowledge graphs becomes very powerful, right? Now, once we have appreciated like how knowledge graph helps us, establish these kind of interdependency, first order, second order, third order relationships, right? So now let us actually go and see, and we have collected enough evidence, right, that why knowledge graphs are needed and how they actually help understand knowledge from complex diagrams, as we saw in the industry, some of the industry engineering diagrams, right? So they make this knowledge searchable, they make this knowledge traceable. So I can actually trace, like, whatever knowledge I have searched, how it is all connected. So how are all the documents which are surfacing, how they are all connected, correct? This is the power of knowledge graphs, apart from just document search. So now let us, look at OpenAI. So typically I'll tell you, when we are implementing a knowledge graph, the process is very painstaking. Okay. So let us go back to our, here, let us go back to the drawing sheet which we had, right? So let's say, I needed this here. So I need to now be able to convert this information into a knowledge graph, right? So first of all, I have to use computer vision to then extract and teach my computer vision algorithms that okay, this is a node, or this is a pipe, and this is a valve, and this is a connector. So I will have computer vision algorithms to extract this information. then I should be able to, then define these kind of entities. So let's say, equipment one is connected to something, or EQ1 is an equipment. This one, see, EQ1 is an equipment. TK002 is a tank, right? So these kind of what I'll say that this kind of relationships I will have to identify, right? So Priyanka is a person, Shulamite is a person, Joshua is a person, Joshua is a host, Priyanka is a speaker. So I will have to identify these kind of relationships, objects and relationships, what we call as ontology. Okay. Then I will have to actually go in my document, whether it is diagram or whether it is, a text content. Okay. So text content, and then I will have to annotate my text saying, this is a entity, what we call as named entity recognition. So I have to annotate some 50 to 100 documents to now actually teach my AI algorithm about these kind of entities. So let's say we have a huge paragraph, right? So let us look at a paragraph something like this. Okay, let us look at a paragraph something like this. Now in this paragraph something like this, this yeah, so in a paragraph something like this, I have to now annotate and say that, okay, so when you say Priyanka here, Priyanka is a person, metaverse is a concept, Microsoft is a company. I have to annotate the text so that, these kind of entities are recognized, and then the AI algorithm learns to do the entity recognition on its own. And it is a tedious task because it's manual. Someone has to, open these documents, they have to mark these entities and then run the NLP algorithm on top of that for doing this named entity recognition. And imagine for an organization as large as the Schlumberger or some oil and gas giants, they will have thousands and, hundreds of thousands of documents. And even if you want to annotate a few hundred documents for a domain, so let's say you have, oil and gas, or you have energy domain, utilities domain, even if you want to annotate a few 50 to 100 documents, that is a painstaking process, right? I mean, then you have to also correct the data which is made available by the machine learning algorithms. And it is becomes an overhead and a deterrent, which is why, companies don't do it. So to have this kind of information unearthed, right, where we have actually this kind of a nice connected graph, or even here, the Azure Cognitive Search, to have this kind of nice connected graph, you have to undergo a painstaking process which can take up to 2 or 3 months. Then later on, when the algorithm learns and fine tunes itself, over a period of time, the time may be reduced, but nevertheless, annotating documents and doing these kind of named entity recognition is a task, which is where then comes OpenAI GPT-3. Okay. So can I use the power of these generative AI and these large language models to take out the pain? And if I tell it a sentence that Priyanka is a person, or Priyanka is a person, she is also a speaker, and she is today speaking at a global AI bootcamp. She has a lot of speaking engagements next week for International Women's Day. So if I keep on typing these kind of things, will it be able to understand that, something is an entity, something is a relationship, and something is another entity, and how they are connected? Is it possible? So this is where OpenAI GPT comes and, helps me, aids me in my journey to build this kind of knowledge graphs. Okay. So I want to show you something here. Sorry. Yeah. Okay, so you look at this, I'm going to paste this in our chat window as well for you guys to go and experiment on your own. Okay, so let me put this on the chat window. So just go and explore this graph GPT. My chat window is not showing up. That's funny. Okay, chat window is not showing up. Okay, Joshua, something to look at, but yeah, nevertheless, let us come back, right? So let's say if I'm describing my graph, okay, so I'm just, yeah, so you see here, let me open this in a new window. Yeah, okay. So you see something called as graph GPT. So now I am giving certain text here. Will it be able to convert it into a graph? You see, I just described a text, and in my text I said Jerry, Kramer, Ellen, George are friends. Then it will give me a graph saying George, Jerry, Ellen, Kramer. So it knew George, Jerry, Ellen, Kramer are entities and friend is a relationship. Now I enter another thing like Newman is, George's, sorry, Newman is enemy of Jerry, but neighbor of Kramer. Then it knows Newman is another entity and this is a new relationship. Okay. And then I'm also giving it instructions like make Jerry light green and other people blue. It is able to do that as well, right? So if I can use open AI for this kind of instruction based learning, sometimes you have zero shot, one shot, multiple shot learning. So if I can utilize these power of OpenAI to actually make a nice working graph like this, my pain of annotation and my pain of actually named entity recognition is taken away, right? And then organizations are free to actually enrich this graphs, knowledge graphs, with more and more unstructured data, more and more documents from various other domains, right? Okay, so let us go back to yeah. So I also wanted to show you, right? So when we are talking of OpenAI GPT-3 itself, correct? You can ask Chat GPT, like what is OpenAI GPT-3 and why it kind of is so powerful. The demo which we just saw also for the Graph GPT, this demo, the demo which we saw for the Graph GPT, right? This kind of why it is so powerful is because OpenAI GPT is currently one of the largest model out there. Okay. So let's ask Chat GPT itself about what is OpenAI GPT-3. So I asked Chat GPT, what is OpenAI? Let us regenerate the response. So my question is, what is OpenAI GPT-3? And it is actually generating the response. It is telling me that it is one of the largest language model with 175 billion parameters, which is huge, which is, absolutely huge. 175 billion parameters is no joke, right? Which is why it is one of the largest and most powerful language models available to date. So it's like, when we teach our kids or, about something, about some concepts, right? So let's say we tell them that a banana is a fruit, an apple is a fruit. And then, they will be able to associate that what are fruits and what are vegetables and these kind of stuff. So these kind of instruction based learning is possible with OpenAI GPT, and then it is how it learns. So if I tell it that, George is a person, and then, George is this part of a sentence is should be an entity, person should be a relation or something like that, or George and Priyanka are friends. So make George and Priyanka as entities and friendship as a relationship between them. So you just need to tell it once or twice what we call it with the help of prompts, and it will be able to auto generate these kind of nodes and entities and this kind of knowledge on its by itself later on. Okay, later on meaning once you give it more text. Okay, so let us look at some of the let us look at question answering using using OpenAI. Okay, so let's say you have this language, you have constructed a knowledge graph. Okay, so after constructing the knowledge graph, how you that knowledge graph will be able to make sense and answer questions. Okay, so you see here, this is the prompt which we said, right? So I'm asking it a question: who won the Summer Olympic men's high jump, right? So now OpenAI knows what it knows. It may not know everything, correct? So it gave me a wrong answer saying Marcelo of Brazil won the gold medal in men's high jump. But I know Marcelo is actually a swimmer. He's not a high jumper, right? So what we sometimes call it as hallucinating. So this OpenAI is hallucinating because it doesn't know the answer. It just, took some keywords like Summer Olympics and 2020 and gave you some answer which it thought was correct, but it is not sure. So what we call it as hallucination. Okay, then what we tell. So this is just a prompt, right? So prompt is, hey, OpenAI, answer the question truthfully. And if you don't know, then say, sorry, I don't know. Don't give me false answer. And I again ask the question, who won the 2020 Summer Olympics? Okay. And then I use the completions model, which is available in OpenAI. Okay. So what is the completions model we are using? Da Vinci. Da Vinci, it is the most powerful model, the latest and the most powerful, right? So I use this model, and then it tells me, yeah, I don't know. So I'm now telling the model, hey, buddy, answer truthfully. Don't just, give me fake answers by keywords. And then it will answer, sorry, I don't know. Okay. Now I want to teach that model some context. Okay, so my prompt is, then I'm giving it some information about men's high jump in 2020, and then I'm now again asking who won the 2020 Summer Olympics. Then it will be able to now and understand this entire context and then give me the answer. Like, Gianmarco Tamberi has won the Mutaz Essa emerged as joint winners. So these are joint winners. Now, what I've done is, it didn't know anything till this part, so it said, I don't know. Say, first it lied to me, so I corrected. I corrected its behavior. Then it answered truthfully, saying, I don't know. Then I taught it. Okay, I gave him the context, like, buddy, you don't know, I know that. So let me give you some context. Now, can you answer me? Yes, it did. Right? Correct? Now what happens is, for small text this is okay, right? So for small text, right, answering that with some few paragraphs or few hundred lines, or few lines or paragraphs is still okay. But what happens when I have to feed it like a huge document with diagrams in it and all of these things? Then how does it work there, right? So how does it, so it will get some information from documents, it might get some relationships from the knowledge graph, and then try to combine them and try to answer my question. Okay, so let me show you a realistic thing here, right? So this is the my context which I have given to the graph, right? Okay, so this is a context where I'm talking of what happens when, at a huge temperature stainless steel pipes are prone to cracking, right? And so on and so forth, because some technical complex operational information is given here, right? And this is something which which, these entities, you remember I showed you the knowledge graph where I'm teaching him what is a pipe, and what is the pipe made up of. So I'm telling him that some part 150 ppg something is a pipe, and that 150 part number is made up of stainless steel, and it carries a flow of 400-degree Celsius temperature. So these things I'm getting from my knowledge graph. This is the thing which, I'm getting from my documents, right? I'm giving the context to that particular OpenAI, right? And then I'm asking a question: which pipe may experience a loss of ductility and why? Okay, so this is my question, right? So now let us, yeah, so let us run this. Okay, let us run this notebook. So now it has read all the context. It has gotten information from the knowledge graph. And now let us see. So my query is, which pipe may experience a loss of ductility and why? The response is, pipe will experience a loss of ductility because, and it gives the reason also, that it may experience a loss of ductility because it is blah, 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 and all of those things. Correct? So it understands context. It understands extra information from your, what was my question? Yeah, okay. So it understands the information, it understands the context, and then it will be able to give you answers, right? So did you see that I was annotating documents anywhere? Did you see that I was actually teaching him, teaching this what is a pipe or what is a something? So that all that effort is offloaded because of OpenAI GPT-3. That this dude can understand context. This dude can, get information from knowledge graphs. Knowledge graph itself, we are building using OpenAI GPT-3 completion models, right? And fine tuning models. And then it is able to combine both of them and give me a holistic answer. And it understands. It can also do inferencing questions and answers, right? So let's say, something like a very nice information. If I tell it that, uh, yeah, here something. If this is a rule, okay, this is a rule. Something is a Martian if it is born on Mars and is an alien. So let's say this is a information which, this is a rule. What we call it as an ontology. Okay, so this is a rule that something is a Martian if it is born on Mars and is an alien. Okay. Now I am telling another piece of information I have is, Behruz is an alien. Behruz is born on Mars. Okay, right? So now if as a human, if I read these two things, Behruz is alien, he is born on Mars, that therefore, if I go by this rule, Behruz is a Martian. So this is what we call as inferencing. Three facts are, two facts and one rule is given to you. I'm inferring based, my human brain is inferring based on these facts and the rule that, okay, Behruz is a Martian. Okay, right? but it is very difficult for language models to do that, right? So if you try asking this question in a Azure Cognitive Search sort of a setting, it won't be able to answer you. But OpenAI knows that. It can understand the context, it can understand the rules, and then it can give you inferencing question and answers as well. So most of our, heavy lifting workload is solved by OpenAI GPT-3, and it makes, using knowledge graph and extracting this insights easier, and probably a process which was earlier, as of last year, taking us couple of months is now done in probably 2 hours, right? So that is the power of OpenAI GPT-3. So I don't want to, bombard you with more complex information. So try and digest this, right? And then we come to the end of our session today. Go and play around with ChatGPT. Go and play around with OpenAI GPT-3. Learn about its power. There are a lot of, GitHub repositories made available by Microsoft. So you can just copy paste that code and play around play around with this information. So yeah. So yes. So any questions I would be happy to take. Otherwise, we come to the end of our presentation.